I have to tell you, I am absolutely thrilled to be kicking off this very exciting series of terrific training opportunities and a chance for this entire ecosystem to come together and really understand where the world is going with computing technology and how each of you can make a huge difference in the market with your innovations that you can bring unlike anybody else. And so today what I'm going to talk about is this concept of 50 billion connected things that are coming. A lot of us have been seeing various reports from IDC or Gartner or a variety of different analysts forecasting how much data we can expect to see with the Internet of Things, forecasting how much the world is going to change in terms of the number of connected devices that we can all expect to see coming. And what's really remarkable for me is how it's completely changing the landscape of technology. It's changing the way humans interact. It's changing the way businesses are trying to find value and innovate. And so what I'm going to share with you today is a little bit of my view on how this is impacting the Internet of Things and technology in general. And then I also want to share with you a bit about what Intel is bringing to market with our ecosystem partners to try to make sure that you as a developer community have access to the world's best compute, connectivity, storage, accelerator, and software, as well as the entire suite of developer tools for the broad ecosystem to really just bring technology to life in ways that no one else can imagine. Now, let me switch over to sharing. All right, so I'm Brian McCarson. I'm a senior principal engineer. I've been with Intel about 17 or so years, and I'm currently the CTO of IoT strategy, and I work in the Internet of Things group at Intel. This concept, 50 billion connected things are coming. When we talk about this, it's a bit difficult to fathom. You know, I can't tell you that I have the ability to comprehend that many connected devices on the planet. It's really phenomenal to imagine having roughly, you know, for the 7 billion people on the planet to have, you know, roughly 5 to 12 connected things per person, depending on what geography you're in. And you know, as you think about this, and you think about what aspects of our lives, what aspects of smart cities, transportation, aviation, consumer electronics, the retail sector, the whole entire industrial realm, there's going to be no aspect of our lives that aren't benefiting from and significantly transformed as a result of this tremendous transformation that we're seeing right now. Now, some people ask the question sometimes, well, what's really fueling this? Because we've had connections to the internet for decades. How are things really changing now compared to where they were 10 years ago? What is making this explosion in connected things possible? And the simplest answer I can give for that is the cost of compute connectivity and storage is dropping at such an incredible rate that we can place compute in places we never dreamed possible before. The best statistic that I like to give is the estimate of how much it costs to produce a single transistor, just one switch, the core unit of compute technology that creates the 1 or the 0 that we're all used to coding in. That single switch that can turn on 5 to 10 billion times per second. Think about that. One transistor can switch on and off up to 5 to 10 billion times per second. If you wanted to turn on and off a light switch, 10 billion times, it'd take you 200 years to do that if you went as fast as you could and never took breaks and never slept. So to have one transistor that can switch that fast, and the cost of that single transistor is less than the cost of a single grain of rice to be grown by a rural Chinese farmer. A rural Chinese rice farmer growing the simplest food unit we have on the planet is a more expensive endeavor than it is for us to produce a transistor that can switch on and off up to 10 billion times per second. So we're really at an era where compute, connectivity, and storage have become so inexpensive, it allows the software developers and hardware developers on the planet to be able to place computing power in areas that we never would have dreamed possible. If you think about what's happening in the realm of autonomous vehicles as an example, we've got so much innovation going into autonomous vehicles that you practically have a data center on wheels. You've got so much compute and connectivity and storage that you can consider having that level of compute behind the wheel of a premium vehicle, even just in the next 3 to 5 year time frame. And already we're seeing vehicles that are produced today with some driver assistance systems that require an intense amount of compute. None of these things were even imaginable 10 years ago, unless you were going to build a car for $500,000. And now these are actually becoming a reality. Now, I want to describe for you the value of IoT and this virtuous cycle of growth that Intel's trying to provide to the market. So the core of our value really starts at the hardware and software level, both in the cloud and data center and in the things and devices of the world. But we connect that together with these accelerators, whether they're FPGAs from Altera, whether they're ASICs from Movidius that are used to help accelerate workloads, and in tremendous innovations in solid state drives for storage, and even new innovations with 3D XPoint and Optane technology. And we bring all that together with connectivity from things and devices all the way through to the cloud and the data center. And we value ourselves based on the experiences that we can provide with all of those assets. Now, we provide those across all 3 phases of IoT. Now, you may not be familiar with the phases of IoT, so let me provide my own brief explanation of what we mean by phases of IoT. And what is a surprise to some people is how advanced some market segments are today. If you've flown on an airplane that's a commercial airliner, you've flown in an autonomous vehicle. An airplane is, almost all commercial airplanes are able to take off, navigate, and land fully independently. The cockpit is filled with a pilot and co-pilot, and he or she are in there in the event of emergency and to help bring the vehicle, to bring that huge machine to and from the gate. But the taking off, landing, navigation, the real-time elevation mapping capability, all of this, including how that machine maintains its stability as it's flying, all of this is done with functionally safe, real-time, autonomous systems that are providing an additional degree of safety than what any human can, because we reduce the risk of human error. So we're already living in a world, and many of us are experiencing the benefit of autonomy on a daily basis, or whenever we travel, if you're a frequent traveler, maybe on a daily basis. But a lot of us are experiencing this and may not even realize it. But there are other market segments where the assets that are out in the field still need to be connected. We're starting to see an explosion in connected devices in the home with Wi-Fi, Zigbee, Z-Wave enabled door locks and electrical outlets and light switches. and all of those are starting to connect to hubs. Those are a combination of smart and connected things, and they're also us using smart and connected things to help connect the unconnected. It's to give you access to information that wasn't available before. In the industrial segment, though, you may have a factory that has been in operation for 20, 30 years, and it has an intense amount of infrastructure, millions of dollars of equipment that may or may not be even remotely ready for connectivity, and you might be needing to provide a gateway or some other device to be able to connect that unconnected asset. But there may be a more advanced factory that's more state-of-the-art, like what you see in the semiconductor sector, in the automotive sector, or some of the consumer electronics manufacturing sectors. And those factories are actually already becoming smart and connected, and some of them are even implementing some autonomous features. The reason why I wanted to share some of this with you is I really think that it's important for you to be thinking about the market segment that you want to serve, and to be thinking about what stage of IoT, what phase of IoT is your customer or the market that you're trying to develop for in. Whether it's making bicycles smarter, whether it's making motorcycles or mopeds smarter, or vehicles smarter, or smart homes, smart cities, retail deployments, or the whole range of consumer electronic devices. Understand where it is that market segment is in the phases of IoT, and that will help you better understand the best possible way that you can bring technology to that market segment in a way that's going to help unlock the full potential. Now, another thing to consider too is if you look across different companies, if you think about what companies are truly innovating in the market today, the companies that are pushing their products to a later phase, the companies that are competing with the market by, instead of connecting the unconnected, they're trying to build smart and connected things. Or companies that, instead of just trying to build smart and connected things, are building in the capabilities for machine learning and deep learning, cognitive neural networks. They're looking at ways that you can deploy artificial intelligence capabilities directly onto those devices to add even additional value. You may have a chance as a developer, when you're developing the next thing that's going to be in the market, to be thinking about those phases of IoT and how you can differentiate what you're building to create even new value that even the competitors in the marketplace aren't developing. Really find a way to capture true innovation. All right, I'm gonna go back to presentation mode again. So Intel is making some big bets, and those big bets are gonna help all of us do a remarkable job at trying to bring new value to end customers. Obviously, I already talked about Moore's Law leadership. Moore's Law, this concept that the cost of developing compute performance will continue to make breakthrough performances year after year after year. We're still living that dream of having that continued innovation. The CPU leadership that Intel provides is still very present and relevant. Of course, we've got the entire suite of Atom, Core, and Xeon products that provide fantastic capabilities. We've got graphics leadership as well, leadership in software and security. But in addition to those core capabilities, we're making tremendous investments in 5G. It's very clear that if you look at the volume of data that's coming through and the forecasts of future data volumes and the need for you to have an entire array of operating conditions, from streaming very high volumes of data to having very low power devices that can be extremely efficient and live on a battery life for a long period of time. The 5G work that's going on to develop those capabilities right now is going to really help us continue this evolution in technology and innovation much much farther into the next decade by adding additional capabilities. We're also investing heavily in artificial intelligence. If you're interested in AI, if you're interested in machine learning and deep learning capabilities, you should take a look at what Intel has with the investments that have been made recently in Nirvana, and take a look at capabilities that we're providing for deep learning with some of the hardware assets ranging from Xeon and Movidius and Altera. There's a suite of devices where you can use the hardware to try to have fantastic new capabilities where inference and training can occur on the things and in the cloud in more efficient ways than we could have imagined possible even just a few years ago. Virtual reality, merged reality, augmented reality, you'll continue to see Intel making significant investments there. This is obviously a very huge growth area for the entire industry. And naturally, automated driving. Having the capability of a vehicle to drive itself is a fantastically interesting value proposition for a lot of people. And we're seeing that market accelerate rapidly, and we're making some very big bets to make sure that we're able to deliver the best quality products, both hardware and software, into that market segment. Now, ways that we're investing in our future meaning all of us, everyone who's on this call. We are continuing to make investments in Xeon Core, Atom, Quark products. I've talked before about this fantastic Optane memory technology that's now ready in the market, in addition to providing the industry-leading solid-state drive technologies that you've been seeing deployed in the market for many years. And seeing this incredible capability of having field programmable gate arrays through the Aria, Stratix, and Cyclone family of products through Intel, with the company Altera that's now part of Intel. We'll continue to have innovations coming out on a regular basis in our silicon technology. But we don't stop there. If you look at the lower left, the software and technology, from making sure that the amazing products that are being developed by our partners with Microsoft and the capabilities they're bringing both to IoT and beyond, the work that's being done with the Linux Foundation and pushing towards real-time Linux capabilities, and of course Google and Android, making sure that everything that we have is able to seamlessly interoperate with the fantastic suite of operating system and software assets of these partners is going to continue to be paramount for us. We know that the combination of hardware and software is what really brings value, and so we'll continue to make significant investments there. We also have a suite of assets for data and device management and orchestration and real-time control systems through Wind River, and we'll continue to make investments there. If you look at the critical technologies that we want to bring to market, I've already mentioned 5G. Of course, we have deep learning and machine learning capabilities that we're bringing to market. FUSA, functional safety, is critical when you have autonomous systems that are important for keeping people in and around them or assets in and around them safe. And so having functional safety capabilities is something that more and more businesses and developers are having to consider when they're thinking about pushing the envelope of what systems and machines can do, to make sure that they have integrated into those systems and machines the capability to always fail in a safe state. Just in case something goes wrong, you need to be certain that the people that are working in and around that system are safe and uninjured. Computer vision is really, it's an incredible field that is accelerating on a daily basis. It's remarkable to me how fast the capabilities are of high-resolution cameras at a very low cost. You can put high-resolution data collection capabilities for video in places that you never would have thought possible, because form factors are getting so small, and the price points of these systems are getting so low that you can put high resolution video capture capability in places you never could have even just a few years ago. And we're starting to see that because compute technology is improving at such a rapid rate, you can actually transform that raw stream of data into value right at the camera or right at the NVR not far from it. And the investments Intel has made in Movidius is a very significant advancement in the ability to turn raw data coming off of a camera into information very quickly. And I'll show you a demonstration later of what I mean when I talk about use of these accelerators for image processing. But I think it's really fantastic to think about what you can do when the camera itself becomes smarter. If you're thinking about having a 4K resolution camera sitting outside of a retail store or sitting outside of a parking garage to monitor who's coming in and out of that parking garage, or to automatically open up the parking gate when you're able to recognize a vehicle that comes in with a specific license plate that's already captured in your locally stored metadata catalog. When you think about what kind of capabilities you can do with a high resolution camera, it becomes fascinating. But there's also a challenge. Like, do you really want to stream 4K video all the way to a cloud application and then perform the analysis there and then send back any information that's needed for actuation, whether it's open up the gate or send a welcome message or update your advertising because you have a new patron walking into a store? When you think about how you could use that information to have even more real-time and local capabilities on camera or near camera in an NVR, you really have a terrific opportunity to turn raw data into useful information locally, and then only have to transmit to the cloud what you think is most critical, just perhaps even just event logging type capabilities. And that can result in lower cost of ownership for those solutions as well. So applying those ML, DL, accelerator capabilities directly on the things can actually give you not only interesting and cool technological capabilities, but it can also provide lower cost of ownership by making it easier to store and transmit only the information that's most critical for your end customer. Security is table stakes. We're going to always have to have robust hardware and software level security, and Intel's made huge investments in making sure the products that we ship are equipped with the tools that you need to be able to make sure the right level of security is being applied for the use case that you've got. Time coordinated compute and time synchronized networking, TCC and TSN. These are two capabilities that are really essential when you're going to have a number of things talking to one another. If you could imagine a array of drones that are working in unison with one another, and you want those drones to be paired with each other so that they can avoid collisions or they can coordinate some function, you're going to want to make sure that all the drones themselves and the compute that's coordinating them is all operating on the same network time clock. And as those capabilities become more critical and time becomes more of a factor when you start needing millisecond or sub-millisecond coordination, the importance of having a synchronized network and the importance of coordinating the compute that's happening in each individual device becomes more and more important. And we're providing some of the fundamental technology building blocks that are required to make sure that TCC and TSN are capabilities that can be deployed in these real-time or near real-time solutions that are out in the market. And of course, I've already talked about artificial intelligence. So what I want to show you now is just a brief demonstration of the kind of capabilities that you can bring to market when you utilize some of the assets that Intel has for accelerating workload. This particular case is pedestrian detection. And here we're just using two loops. It's the same video loop in each of the images that you see, both on the left and the right. And the loop is, this is a recording of how that loop was processed through two different workload configurations. In red, the one on the left, is where you've got a CPU only. And this isn't just a low-grade CPU. This is a Gen 7 Core i7 product from Intel that is demonstrating the capability of roughly 18 to 19 frames per second. FPS is frames per second. So this is showing you how many times can that compute engine analyze what's going on with that video stream per second. And it can completely analyze up to 18 frames in a given second. And when it does that analysis, it's looking for conditions that meet the requirements for what it considers to be a pedestrian. And when it meets those conditions, it highlights and flashes with a green box to say, hey, I found a pedestrian here. And that is an event that can be logged. So you could imagine having a camera that's, like I mentioned before, right outside a retail store, and to be able to have that camera keep track of how many people are walking by the store, how many people are coming in, what's the demographics and age and gender of people coming in, how many people are coming in as individuals, how many people are coming in as groups, and can I take that data and turn that into value for a retail store or for whatever application I'm using this for, to give them more information about what's going on with the people that are visiting that location. But what you see if you look at that red bar at the bottom of that CPU only graph is it's taking about 70% of the CPU's capacity to run that 18 frame per second capability of that pedestrian detection algorithm and processing that video loop. Now, if you add an accelerator to that same platform, so in this case, it's just one board. We took that exact same board and added an accelerator to it, a graphics accelerator. If you place that graphics accelerator, and in this case, just in the PCIe slot on the same board, and you have that graphics accelerator capturing the bit stream for that data set that's flowing through that system, and let the accelerator that's been tuned and optimized for video processing, have that accelerator do that same pedestrian detection capability, you see that you can work all the way up to 2x the frames per second. In this case, we've got up to 36 frames per second. And the CPU usage drops down to the 9 to 11% range. So what that means is now my CPU is either not consuming as much power. In this case, adding an accelerator actually cuts your total system power in half, surprisingly. So having an accelerator board plus your CPU is actually lower power than just having a CPU alone working on all of this. That frees up your CPU to be running additional analytics capabilities, to have other applications for notification, for sending alerts to someone that there's something else that can be done with the data that's being received. You have more capabilities for that CPU to be doing what it does best, so that the accelerator is the one that's the general purpose workhorse of choice for making sure that you've got that in this case video stream being sufficiently processed in a way that's going to be much more efficient than what a CPU alone could do. So not only do you get lower latency, you'll notice that there's actually quite a few more green boxes that pop up on the image to the right. because the system is able to do more detection and more frames per second, so the opportunity for it to find pedestrians goes up as well. So you get lower latency, you get much higher throughput, and it's massively better than a CPU only. You can get up to 6x lower CPU utilization, half the power, and in the case of using an Altera field programmable gate array, you can do this in a software-defined, completely reconfigurable format. And having that be completely reconfigurable means that if you have a new algorithm that gets developed, if you have a new capability that you're able to innovate on in the software, but you need to update your accelerator to be able to capture the full value of that, you can do that remotely and not have to go invest in additional hardware to go get that upgrade completed. But we also have some terrific accelerator assets with Movidius, and you'll see more of these products coming out in the years to come, where you've got an exceptional level of performance for video, image, computer vision processing capabilities with these Movidius ASICs, and these deliver an unparalleled level of performance in frames per second per watt, so that you can achieve without having to have expensive cooling equipment that you might need to with an otherwise general purpose graphics processing unit. What you can do is you can really come up with new form factors at lower price points that have the same or better level of compute than what you would get with a general purpose GPU. And all of this can be done using a OpenCL type framework. So you don't have to get locked into any proprietary type developer environments. You have the ability to develop your own innovations and bring your own innovations to market. Now, some other things that we're doing as well is Intel continues to have a strong leadership presence in driving standards and interoperability. We understand the frustration and the difficulty of this incredible transformative phase of technology that we're in, where you have all these devices that can now be connected. And we know that there are literally thousands of different ways across the different market segments that these devices can communicate with each other. There's a tremendous number of proprietary stacks in the market that make it very difficult to get devices to interoperate. And we're trying to help make significant improvements in that. And our partners at Dell and SAP and Schneider and GE and Microsoft and Google and Cisco are working with us to make sure that what we're bringing to market is as interoperable as possible, and to make sure that future innovations are more interoperable than the ones in the past. And we're trying to provide as much open source code as possible, like, for example, through the Open Connectivity Foundation, which is a Linux foundation, and the IoT code base. You know, we're trying to be able to provide, with our ecosystem partners like Samsung in that particular case, the type of code that's needed to really help promote interoperability and make it much easier for developers to unlock the value of these devices without having to go recreate the wheel each time. If you think about areas where this has gone very well, and where Intel's been able to provide this kind of leadership, you think about the USB device, which is something that Intel invented, and was given to the market to try to promote interoperability of how various bits of hardware and peripherals connect into our compute assets. If you think about the fact that you can log in on your laptop or tablet or even on your smartphone and connect to Wi-Fi at a Starbucks or coffee shop in Jakarta or Tokyo or San Francisco or London, and have the exact same Wi-Fi radio be able to enable you to connect with that device worldwide. That's due in part to efforts that Intel co-led with other industry leaders to try to help build Wi-Fi communication and connectivity standards. So these are the kind of things that we're going to continue to invest in, because our promise is that we want to help the entire ecosystem of developers grow and advance the state of technology in the market and bring innovations to the market in ways that we never thought possible even a few years ago. And so, in conclusion, what I'd like to share with you is more of my view on this concept of 50 billion things are coming. And I want to express to you that we're ready. We're ready for these 50 billion things to come, and we're here to provide you with some of the best industry-leading hardware, software, compute, connectivity, and storage products, and provide you with some of the best developer experiences we can to help you unlock and unleash the power of these technologies to create value in ways that we can't even imagine. If you think about where the world is going, and you think about how incredible it is that we're seeing this massive explosion in compute connectivity and storage capabilities, and what that can do to the market, to me it's incredibly exciting. But we need to talk about some of the barriers as well. And when you think about these barriers, how many different products are coming to market, and you think about this concept of 50 billion things are coming, how is the current network going to be able to handle that level of compute capability being distributed across the globe? 50 billion devices accessing and streaming data to and from the network is a really unfathomable amount of data that's going to need to be processed and analyzed and take action on. And the thing that this does is this really creates both a problem and an opportunity. IDC, which is a major and very reputable analyst firm, estimates that even by next year, by 2018, you'll have as many as half of all the IoT devices, half of all these connected things that are coming, will be processing and analyzing and taking action and storing the data locally on the things. So half of all the data generated won't make its way to the cloud on average. Now that's a pretty phenomenal statement for IDC to make, and the implications are tremendous. But the concept is that the pace at which compute is being deployed onto things in the market is exceeding the ability of the network to cost effectively keep up, or the need for real-time decision making is going up so fast that it doesn't make economic or physical sense to try to have that level of compute be dependent exclusively on a cloud type system architecture. So what you have is a scenario where you need to be able to have some systems, and when you have these systems capable of performing analytics locally and behaving autonomously in their environment, you're going to create a whole new value proposition that doesn't exist otherwise. And this value proposition may not only just be something cool and trendy, it may actually be required. If you think about the case of an autonomous vehicle as an example, if your family is being picked up by your autonomous vehicle or an autonomous taxi in 5 to 7 years from now, you're not going to want that vehicle to have to rely exclusively on the cloud to make life or death safety decisions. If that vehicle's driving on a highway, it sees that there's an accident that occurred in front of it, and it needs to evaluate how to avoid that accident. You don't want it to have to go connect to the network, find some data center in Canada or Finland or some other location, and then have that data center make the decision about how the car should respond. You're going to want that decision making to occur locally on those devices. You can't afford the delay, and you can't afford the risk of not having that autonomous system be able to make those decisions locally. So when I think about machine learning and deep learning capabilities, when I think about autonomy, I get really excited thinking about how can we bring these capabilities directly onto the things and then utilize the power of big data analytics by streaming just the events that are occurring, just the processed information to the cloud, so that you can then unlock new information about how these devices are being used and come up with new machine learning and deep learning algorithms that can be deployed on those devices. So this problem that IDC talks about, where roughly half of all IoT networks will be constrained by next year, by 2018, and half of all the data that gets processed will be processed locally on the things and not make its way to the cloud. That's both a problem and a fantastic opportunity. And if I think about what's exciting for developers, it's how can you bring some of that compute capability and that decision-making capability closer to things as these machine learning and deep learning and autonomous capabilities become even more cost-effective to deploy in the things directly, and how that whole suite of compute, connectivity, storage, and accelerator assets Intel's been developing for all of us as a community, how that can be used to try to create even new fantastic value that we couldn't have imagined before. Now I'll go back to sharing my my screen again. So this concept of 50 billion things are coming, and yeah, the networks may be constrained, and yeah, half the data may never make its way to the data center, but that's okay, we're ready. We're ready. When you have a data center-based application, we've got the best solutions on the planet for you. And we're developing some of the best solutions on the planet from a hardware and software ingredient perspective for when those things in the world of Internet of Things, when those things need to be smarter and when they need to be more capable of connecting with each other and with the infrastructure and with the network in new ways, and when they need to be able to start to adapt to their environment through autonomous and software-defined AI capability. And whether it's the suite of silicon assets that we can offer, including the MLDL capabilities offered with Nirvana systems, whether it's the accelerators that Altera or Movidius can provide, or anything from a Quark level to Xeon level compute capability, we're going to have the right silicon ingredients for what you need. Software and technology, whether it's kind of SDKs, the software development kits that you're going to be hearing more about in the sessions to come, whether it's unlocking the power of the various different fantastic OS offerings from Linux, from Microsoft, and from Google or Wind River, whether it's trying to unlock the capabilities of perception detection with RealSense. We're going to be able to provide you with the capabilities that you can use to try to really innovate in some fantastic ways. The memory and comms, we've talked about that as well. That's ready for different market segments. We're going to continue to invest in standards. We're working with the entire system of IoT providers, whether it's equipment builders, solution providers, tech providers, and to make sure that we've got the right technology partnerships to help some of the world's greatest ISVs and some of the up-and-coming ISV startups to be able to connect into that huge ecosystem to find new paths to market and find new ways to deliver value to customers. And we're going to continue to do that across the industrial, retail, automotive segments, smart cities, healthcare, the whole broad market. 50 billion things are coming, and we are excited and we are ready. So that concludes my talk. I love having the opportunity. I'm deeply honored to have the opportunity to speak with all of you. Many thanks to Grace for the fantastic introduction and for hosting this session. And I would have a couple minutes to entertain any questions. So if anyone wants to ask anything on the chat window, I would be happy to answer anything in the remaining couple minutes that we've got. But otherwise, I'm super excited and honored to be here and can't wait to see the incredible products that you as a developer community are going to bring to market. And yes, I'm seeing comments. There will be so many protocols. There are already so many protocols. It's really incredible to think about how many protocols we have to try to translate. You know, you think about exchanging data across systems that speak different languages. It's really going to be a challenge for a lot of us to be able to find ways to get these devices to interoperate. And so the efforts going on with protocol normalization, data semantics, metadata and interoperability in the standards community, I think that's going to be pretty key to try to help us breakthroughs. And IoTivity is through OCF, the Open Connectivity Foundation, is working hard in the smart home and consumer segment to try to bring some of these assets together and normalize out some of these protocols to try to help make it easier. Okay, great question. How much power is needed to run the computer plus accelerator card? 300 watts, 500 watts? David, you would be amazed to find out that if you're going to use a general purpose graphics processing unit, you're talking about adding 300 plus watts or so kind of capabilities to that platform just in the card. But you know, we can do some amazing things, and the example that I showed you was a total system sub 100 watts, the entire system, power supply, CPU, and accelerator combined less than 100 watts. So you can even start to fathom with some of the new Movidius capabilities, some of these run with less than a watt, less than 1 watt. So you can start to put some of these deep learning accelerator tools on environments that can be fanless. Okay, and I am out of time, so out of respect for the next presenter, I'm going to go ahead and finish up. Again, thank you, everybody. Enjoy the rest of your day.